So this is my statistical analysis project. So my dependent variable is diabetes. So this slide just represents the data set of diabetes rate in Canada in 2017, and it also shows a diagram as well. So this slide shows the central tendency of diabetes. So the mean, which is the average of the data set, is 79.2. The median, which is the value in the middle of the data set, is 8.2. And the mode is 8.9, and those are the values that are present the most in the data set. So I also have the measures of spread along with a histogram graph in the top corner. So the range is 3.6, and that's the difference between the highest and lowest point of the data set. Quartile 1, which is the 25th percentile, is 7. The IQR interquartile range is 1.8 and 84, and the variance is 5,082. And with that is the square distance that each data point is from the mean. Then the quartile 3, which is the 75th percentile, is 8.84, and a standard deviation of 71.28. So the distribution is the diabetes rate data is distributed in a mound/normal shape because in general the data tends to decrease as we move from Newfoundland to British Columbia. So my first independent variable is obesity. So here again is the graphs and the data set for obesity rate in 2017 in Canada. And the central tendencies, so the mean is 30.9, the median is 29.5, and the mode is 35, 38, and 29 because they all three appear the same frequency, but they appear more than the other numbers. So for measures of spread, I also have another histogram graph in the top right corner. So I have the range of 16, quartile 1, 26.6, interquartile range is 8.6, variance is 26.09, quartile 3 is 35.2, standard deviation is 5.12, and it has a z-score of 1.74. So the distribution is a mound shape because it mainly decreases, and the median is roughly at the same as the mean. So identifying and removing points. So for this, I removed points which were the outliers, so that was where the farthest from the average of the data set. So for obesity, the impact of the BC 0.22 causes the trend line to become flatter and the y-intercept to slightly decrease. So we can see here that the trend line is a little bit lower than the one of over here. So correlation type. So the correlation type for obesity is a moderate negative relationship, which is a low correlation. And I thought that it was an accidental correlation because the farther west, which is the farthest from Newfoundland to British Columbia, the rate of obesity decreases. And I believed that there was no reason why people would be more obese in the Newfoundland than in British Columbia because they have no less accessibility to exercise to decrease the obesity rate. So my second independent variable is mental health. So here again, I have two diagrams of the data set and a diagram representing the mental health in the Canadian provinces. And the central tendencies, so it has a mean of 7.38, median as 7.3, and a mode of 0 because there is no number that repeats itself more than once. Measures of spread, so again I have a histogram in the top right corner. The range is 4.1, quartile 1 is 6.6, interquartile range is 1.56, variance is 1.17, quartile 3 is 8.2, standard deviation is 1.1, and the z-score of 2.12. So the data is in a bimodal distribution because it has two peaks on the ends of the data and the points in between are lower than the peak data points. So again, identifying and removing points. So for mental health, the impact of the Quebec point 5.1 changes the trend line to become flatter and causes the y-intercept to slightly increase. So again, over here, we can see how the trend line is a little bit below our 8 right here. And then over here, it's a lot closer to and almost exactly on the line. So for the correlation type for mental health, I thought it was a strong positive relationship. It's not exactly perfect, but it is a very strong correlation. So the mental health rate increases as we go from Newfoundland to British Columbia. So therefore I thought it was accidental because it could be due to the warmer weather in the west, because warmer weather is known to cause happiness, which therefore leads to lower poor mental health rates. And also my explanation for this is that the location of the provinces and the warmer weather in the west would make it seem like the data should decrease. However, it does increase. Therefore, it is an accidental trend because there's no direct correlation. So these are my 3 diagrams. It's obesity, mental health, and then the comparison between the two. So obesity is a negative weak correlation at around negative 0.33. The meaning of the slope is that the obesity rate trend tends to decrease as we move from Newfoundland to British Columbia. Mental health is a slightly positive correlation and is a weak positive correlation around 0 to 0.33. The meaning of the slope is that there is a slight increase in the mental health rate as you move from Newfoundland to British Columbia. Y-intercept shows that no matter what province you are in, the highest obesity rate is 36. The y-intercept is the dependent variable. The y-intercept of mental health shows that no matter what province you are in, you would have at least a 7% poor mental health rate. So now correlation type of obesity and mental health. So the correlation in the comparison chart between obesity and mental health is a weak positive relation, and it is a cause and effect and also reverse cause and effect, because obesity can cause mental health and mental health can cause obesity. Because if you become obese, you're more likely to become self-conscious and have poor mental health, but also having poor mental health can cause bad eating habits, which can lead to obesity.